people involved and hopefully get more people doing some of the hands-on stuff that I found just fascinating, amazing. I have gone down the YouTube hole and almost didn't get back, so it's been a lot of fun. But just a quick outline before we start looking at some of the examples and some of the things I hope we can cover over the next few months when the weather starts getting nice. The common mode choke to block RF coming back into your shack, also used for dipoles. It's a 1-to-1. I have several examples of that up here. We'll take a look. The 49-to-1, which is the one that I think we'll start with and actually show you a finished product. Either 49-to-1, we can do a 64-to-1, or there is a multi-tap, which is variable, depending on how we're using it, what we find when we do the testing. Very advantageous to have if you just have to have one. 9-to-1 random end fed, sometimes referred to as a long wire. There's a winding of that here as well in a jumbo pack, probably able to handle 1500 watts easy. 4-to-1 balun. I don't have an example of that, but those are primarily used for off-center fed dipoles, loop antennas, different things, but that is real easy to wind as well, and depending on the application, that may be something you'd be interested in. We have examples of rigs for portable QRP, something to throw in your backpack. A lot of us that are doing the drills out there, set up mobile, wagon wheel, thank you Rick, we've utilized the G90, 25 watts. Perfect radio to work one of these smaller units without overtaxing it. Much more portable than something that comes in a big box, although this, is perfectly usable as well. But if you have the option to go to something like this, that's the same thing, only smaller, and these can be smaller yet. Here's an example. Same thing, with the winding and everything in it. You know how easy it is to build this? And compared to what you pay to buy it online, far less than half price.
I've got probably $6-7 into that little one built out of the pill bottle. That one, in the kit form, was $25 with the wire and everything, so.
Okay. And we can build these very easily.
Yeah. The other one, the white one, is made out of a breadboard, a little 97-cent Walmart board.
Okay.
The Toroid is about $6.
Yep.
A few dollars with a wire.
Yep.
There's really nothing to it, and that'll work all bands.
And how easy it is to wrap everything up, throw this in your backpack. Excellent, excellent.
But it's low power, 15-20 watts for the smaller ones, 50 watts for the bigger one. So
Yeah.
all low power stuff.
And depending on the type of toroid that you're getting, whether you're using a single or a double, and the size of the wire is going to determine how far you can push that. Hopefully we're going to do ones that are in the 50 watt range or below for portable, the smaller stuff. Diameter of the wire makes a big difference, and whether or not you're using 1 or 2 toroids stacked makes a big difference as well. So depending on your use, how durable you want to make this, how much you're going to go out in the field and just abuse it, we'll build it to your specifications. I don't know if we can help that or not. Anyway, for that portable QRP backpack, and then testing and some of the different ways to tune what we can get with wire diameter, things like that, what that does to your antenna when you're done. Wire diameter increases the spectrum or the width, how much bandwidth in that 20 meter, 40 meter that you're working in, how wide of an area you're going to get that lowest SWR. What's the range? A lot of that's determined by wire. So we can test that. Any of the rig expert things, you can do it manually if you have the MFJ tuners, or VNA also does a good job in finding those parameters and knowing what they are before you go out there, or building it with certain specifications in mind gives you the confidence to go out there and run your equipment efficiently. And how do we tweak it? How do we, if we find something in that testing process, how do we tweak that back into where we need it? It's not always cutting the wire, making it shorter or longer. It might be, like I mentioned earlier, in that tap of a 49-to-1, maybe we need to get that back down to a 42. Take one wrap off of that. Instead of a 2 to 14, we do 12 or 13. How do we make that testing tune in for what it is you're looking to accomplish? Where is it short? Where can we tweak it up? Sometimes it's as easy as spacing on the wrapping because of the interaction that it has going through the electromagnetic field of the wire next to it. If we space that out evenly or closer, what does that do for it? All of those things are things that I would hope to cover. Anybody's interested in doing this.
Would a resistor work on that?
For testing?
Small resistors for bringing it down?
No.
It won't, no.
You don't need that.
Okay.
If you want to come on up and take a look at some of the different items that we have that are involved. This is a completed one that I just took out of my backyard.
A little bit of water.
Yeah, and one of the things that I learned, but didn't learn soon enough, is the different components that you use. Zinc coated nuts and bolts, yeah, they're a little bit cheaper, but I'm gonna have to take this one apart and redo it because it's getting rusty down in the bottom, or I didn't put sealant over it, different things like that. So we can learn from each other's mistakes, what it is we can do better next time. But if you want to just take this and pass it around, this is basically a 2-core, 240-43 is the toroid on that. It's a 49-to-1. Between the center portion of the coax and the shield, there's 2 windings. Here's another one here in a smaller form. 2 windings together, and one comes out this side. The other portion of that goes out the top for the antenna. Between the positive and the negative side, there is a capacitor. 100 picofarad capacitor is the typical one that gets used, and that is to kind of help out with the upper bands a little bit, from what I understand. Not necessary with the lower bands if that's all you're going to use it for, but in the upper bands it becomes critical to get into, especially 10 meters, maybe a little, some of the ones just down from that. But those are all things we can test with or without. What does that do? It's nice to know. real power hungry guys out there that maybe are gonna do this from home, this is a 240-31, which is a little different mix in the toroid, typically used for getting better common mode rejection in the lower bands. 31 has a little better drop, lower into 160, things like that. This is wound with Teflon coated wire. I peeled back one side. I will say that if you're gonna work with the Teflon wire, it's a pain in the you-know-what.
Pain in the rick?
It's a pain in the rick. Yes, sir.
You have to take this coating off, don't you?
Yes.
You have one here? Okay.
Yeah. It's enamel coated, so you have to peel it back so that it solders correctly. And this is an example of the 9-to-1, and I've got a drawing up here if anybody wants to look at it once we finish up here. But I'll pass this around as well. This is a 9-to-1 for a random end fed. That one, I'm assuming, is probably capable of doing full legal limit.
1,500.
With 331 or 343 cores and that gauge of wire, easily do that.
The only difference with the random wire is you have to have a tuner.
You have to have a tuner.
49-to-1, we try to make it resonant.
Yep. The purpose of the random wire is if you are in a situation where you don't have the ability to string up a half wave, a full half wave, you could cheat with a 9-to-1 and do a variety of different lengths to get anything that is not resonant. And just an example, I'll read off a list of wire length that's usable on a 9-to-1 unun from 160 through 10. 53 feet, 59 feet, 72 feet, 88.5, 98.5, 124.5, and that one's got an asterisk by it. Apparently that's a really good length to have. 135, 146, 162, 175. Typical SWR on something like that is about 2.2-to-1. Sometimes very easily to handle with a onboard tuner, but a tuner of some sort is needed to bring that down under 2-to-1. There are some alternate lengths, but that'll give you an idea of the different varieties, and any one of those lengths will get you on 160 through 10 with a tuner. The 49-to-1, the first one going around in the box, that one has to be cut for a specific length. Typically we're going to use, and there's a formula for that, depending on the lowest band you want to start with. Let's say you wanted to do a 40 or an 80 through 10. Okay, 80 meters is what, 3.5, somewhere in there, and the formula for that is 468 divided by the frequency in megahertz, and that will give you the wire length. Okay, and that works out to, what is that, 130, 135, somewhere in there.
And this is for the 49-to-1?
This is on the 49-to-1. One of the things with the 49-to-1 that makes it so acceptable and nice to have is whatever the lowest frequency you cut it for, if you cut it for 3.5, it's also resonant on multiples of that. So as you double 3.5, you get 7. That's another ham band.
40 meters.
Okay? Add another 3.5 to that, it's also resonant on 10.5. It's also resonant on 14. It's also resonant on 17.5. On 21 or 22, whatever that is, okay? And, yeah, 21 and 28. Okay? Any one of those adding 3.5 through here, there's a dip in the SWR, getting it resonant at those frequencies as you jump through this. Okay? So it's a multi-band antenna winding that allows you to pick wherever you want to operate. Now, sometimes you can't always do 135 feet. I have one at home that's half that length, so I don't get the lower bands, but it still works for 40, 20, so on 10, but I haven't played, I've got a different antenna that I use for 10. But it works awesome on 40 and 20. Just done. So those are some of the things that we can play with if you're interested. Like I said, I've got some examples up here that Randy brought in a bunch of small stuff that he's looking for. He showed me this one last week. This is that 49-to-1, like what's in this box, done with a pillbox. If you have a little ingenuity, creativity, or a junk drawer out in the garage, the parts to do this are everywhere. Some of this wire, like this is a 1-to-1 choke. That's some speaker wire that I had in a box that's been following me around for
Hold on.
probably 30 years. Okay?
Sorry for the zoom.
Projects, if we plan ahead a little bit, that's a project that can be built in an hour, hour and a half, couple hours. To give any one of these items the attention that it needs to talk about it, do some testing, things like that, or just more discussion, probably a half hour, 45 minutes on any one of these items to really cover it, and then a suitable amount of time to actually build it. So I'm open to helping anyone or joining in anyone that has an idea that they'd like to pursue this with. Rick has nicknamed me the antenna farmer, so I'm gonna go ahead with it. Okay? You wanna plant some seeds for some antennas? I'll do that for you.
What about a power?
I'll do that. So, come on up, take a look around, ask any questions, anything
Yeah, I
like
got a
that.
question.
Yes, sir.
How rugged are these cores? I saw you dropped one on the table. Is that okay?
Yeah, they're pretty tough.
Will they crack?
If I hit them with a hammer, they might. I haven't tried that,
Pretty rugged then.
but yeah,
The wire will give them some cushion too.
yeah.
Frick didn't break it, they gotta be very good.
So, anybody have any other questions?
Are they powdered metal typically?
These are not metal. I'm not sure the exact composition, but I can look that up, find out for you. They do have metal ones that are more metal, but these are non-conductive, so they're not metal. Like I said, I don't recall the material that they're made of, but it's something we can look up.
It's ferrite or something like
Yeah,
that?
I
They're-
was just gonna
it's-
say, yeah,
Ferrite, whatever ferrite is, I don't know.
special need.
It's a mix, yeah. think it's 36 or 38 or something.
I was thinking a mix of something with ceramic.
And
Possibly.
that very well could be some type of carbon base, I would assume, but
I know the ones you don't wanna use for this are the, iron powder,
yeah.
those, I know,
Yeah, the iron powder ones, none of what we're talking about here, those are applicable for. But any one of these 43 mix, 31 mix for the chokes, the different sizes. There is a 51 also that in some instances that might be preferable, but these are pretty basic, cover just about everything between those two. And they come in a variety of different sizes. 240 is the like 2.5 inch. This is a 140, and then this little thing here, we bought this. This was made by somebody in their garage, and they turned it into a business called a spark plug antenna. And basically, it is a BNC connector super glued into a piece of PVC shoved down into the middle of a smaller toroid wound with ultra light wire, and then out through the top is a brass screw where you hook on the wire for your end fed.
Looks like a chair.
So this guy was sitting around going, what am I going to do today? Look at, he's got a business going out of it. Okay. One of the other things that we had talked about here a while back, I had some brainstorm. I got down in a rabbit hole, and actually this is part of that rabbit hole experiment. What happens if I want to take a box like this, maybe smaller, but maybe not. If I had some smaller toroids, I'd use those. I got a box that's big enough to hold 2 toroids. Okay? One is going to be the choke. This 1-to-1 stock common mode or used for dipoles, either one. And a 49-to-1 as well, so I could run an end fed. But what if I wanted to do both, a dipole or an end fed? Right? I want one box that I have some options with. Or maybe I want to put up a vertical, and I've got an antenna that screws into the mount, but I don't have a way to do that out in the field. Can I do all 3 of those in one box? Why not? Might need a switch to disconnect between the choke and the 49-to-1, say a double pole, double throw switch to send it instead of through to the 49-to-1, how about to the dipole? Or to the mount that sticks out the top of the box that would hold your antenna. How many of you have those antennas with the 3/8 by 24 screw-in connection? Okay. What if you had one of those connections on that box? And you're out somewhere, say with your car, you got a bumper, you put a 5-foot pole on it, screw your antenna onto that. You're good to go. Why not? What do we want to do? My question to you is, why not? That's all I got. Thanks.
Cool. Thank you.
yeah.